Our today's topic is electric current. But before going into the definition of electric current, I would like to give the general meaning of word current. Current is associated with motion. Whenever a thing is in motion, we call that as current. Say for example, if the water is in motion, we call that as a current of water or water current. Similarly, when the air is in motion, we call that as air current. For example, we have a pipe here. The water that is flowing through the pipe, we call it water current. But when the same water is stationary in a tank, we simply call it water. So the difference between the water that is flowing through a pipe and the water that is lying idle in a tank is that the water in the pipe is moving while the water in the tank is stationary. The water that is moving in the pipe, we call it as a water current because it is moving. Current means something that is moving, whereas the water in the tank, we simply call it water. Same case is with electrons. If we take a conductor, in a conductor there are already electrons present. Electrons are negatively charged, as you know. When these electrons are not moving, they are stationary, we simply call them as electrons that are in a conductor, say in a conductor that is made of copper or the conductor that is made of iron. They cannot produce any current. But when the same electrons are in motion, when the same electrons are moving, they generate current. We call that as electric current. Current means something that is moving. Here the electrons are moving, electrons are flowing, electrons are in motion. We call that as electric current. So here is the definition of electric current. Electrons is a flow of charge through an electric conductor or through a circuit. If you want to measure the electric current, there is a unit for it. That unit is ampere. Ampere is the SI unit of electric current. Ampere is also called as coulomb per second. So SI unit of current is ampere, or it is also called coulomb per second. If you have to find how much is the 1 ampere of current, you have to take 1 coulomb of charge, you have to make it flow through a conductor for a period of 1 second. If you take a 1 coulomb of charge, and if that 1 coulomb of charge passes through a conductor for a period of 1 second, it will generate an electric current equivalent to 1 ampere. Electric current is denoted by symbol I. Symbol I. Electric current, mathematically, if you have to derive equation so as to find the value of electric current mathematically is equal to Q divided by T. Mathematically it is equal to Q divided by T, where Q is the charge, amount of charge, and T is the time period for which the charge has been flowing through a conductor. Here you can see that I is equal to Q divided by T. And as I already said, the SI unit of current is ampere and it is represented by symbol A. Say for example, if Q is equal to charge is equal to 10 coulomb and the 10 coulomb have been flowing through a conductor for 5 seconds, and we have to find what is the amount of electric current that is flowing through a conductor. As you know, I, electric current, is equal to Q divided by T. So as Q is equal to 10 and time is equal to 2, so electric current will be 5 ampere. This is a way to find the value of electric current. If you know the value of charge, that if you know the amount of charge and you know the time period for which the electric charge has been flowing through a conductor, you can find the value of I, value of current, which is equal to Q divided by T. There is an instrument by which we can find or by which we can measure the electric current that is flowing through a conductor, and that instrument is called ammeter. So ammeter is an instrument that is used to measure the electric current that is flowing through a conductor. Suppose if this is a conductor and electric current is flowing through this conductor, we have to join ammeter here, and this ammeter will give us the exact amount of electric current that is flowing through this conductor. And ammeter is always connected in a whenever we connect ammeter in a circuit, we have to connect it in series. Series means we have to put this in the circuit. We have already discussed that current is a stream of moving charges. It is a flow of charges, be that electrons or protons, and this current can vary as per their magnitude. For example, if the value of current is very small, you can take the example of narrow impulse. Current is flowing through our nerves in the form of narrow impulse, but that current is very small in magnitude. There are also the currents that are very high in magnitude. Take the example of solar wind that is emitted by the sun. It is very large in magnitude. So the current can vary in terms of magnitude, and there are also examples of current that we can find in nature. Say for example, narrow impulse, solar wind. These are all examples of electric current that we find in nature. But here important point that we have to note is that whenever the charges are flowing in a conductor, say for example, you have a conductor here, and within this conductor there are electrons. And when no battery or no source of electric current is connected with this conductor, there will be no electric current in it. But remember one thing, whenever when the electrons are already present in the conductor, and these electrons are actually in a continuous state of motion, but still there is no current. So I am making earlier I put out a definition of electric current, that electric current is electrons in motion. Whenever the electrons are in motion, they will generate the electric current. Here I am saying that if you take any conductor, be that the conductor that is made of iron, or the conductor made up of this iron or copper, there are electrons within these conductors, and these electrons are in a continuous state of motion, but still they do not generate any electric current. So this statement is actually contradicting with the statement or with the definition of electric current, which is the flow of electrons. Here electrons are flowing, but still they are not generating any electric current. There is a reason for it. And what is that reason? Here the electrons are moving, but they are moving randomly. One electron is moving in this direction, another electron is moving in this direction, another electron is moving in this direction, and still another is moving in some other direction. The electron that is moving in this direction will generate an electric current, but still there is another electron that is moving just in opposite direction, that will also create the electric current, but that electric current will cancel the electric current that is produced by this electron. Similarly, this electron will generate the electric current, but there will be some other electron that will move in the other direction, that will cancel the electric current produced by this electron. So here electrons are not moving in any particular direction, they are randomly moving in all directions. As a result, they are creating the electric current, but that electric current gets cancelled by the other electrons that are moving in the opposite direction. So due to this random nature, due to this random flow of electrons, the net electric current produced is zero. Net current produced is zero. So we have to refine the definition of electric current. Electric current is simply not the motion or flow of electrons. Electrons must flow in an orderly fashion and in a particular direction. So we have to refine definition of electric current a bit. It should be and it must be flow of electrons. So electrons must be flowing, they must be in motion, but that motion must be orderly, they must be flowing in a particular direction. Random motion of electrons cannot generate electric current. So if the net flow of electric current has to be produced, they must be in a particular direction, in a one direction. Only then the electric current can be produced. So another important aspect of electric current is the direction. First aspect is the motion, the flow of electrons. The second aspect is that flow must be in a particular direction to produce the tangible amount of electric current. So I am stressing the two aspects of electric current. One is the flow or motion of electrons. Second is that motion must be in a particular direction and in an orderly manner. So when there is no net flow of charge, as I already said, if you take any conductor, whether that conductor is made of copper or iron, and if that is not connected to any source of electric potential, there will be the flow of electrons, but that flow will be random and they will not generate any tangible electric current. There will be no electric current despite of having the flow of electrons. There will be no electric current. The reason for that is very simple, because the flow they are flowing, but they are not flowing in a particular direction or in one direction. They are randomly flowing. As a result, the electricity or electric current that is produced by different electrons will be nullified by those electrons that are moving in the opposite direction. So as I already said, that the flow of electrons must be in a particular direction. So electrons that are moving randomly. One direction is equal to those that are flowing to the other direction. As a result, they will cancel the current produced and net electric current will be zero. There will be no net electric current. Here is a conductor that is not connected to any source of electric potential, and here you can see the electrons here. They are randomly moving. So as they are randomly moving, they cannot generate any electric current. Now we have taken a conductor and we have connected it to a battery. Now what will happen? Electric potential will be created. This battery will push this electric potential that is created by this battery. They will push the electrons to flow in an orderly fashion. And this orderly fashion, or this orderly flow of electrons in a particular direction, will generate electric current. It will produce electric current. So I am emphasizing and saying this thing again and again, that electric current will only be produced when there is a flow of electrons, and that flow of electrons must be in an orderly or in a particular direction. Here a source of power, that is battery, is actually forcing the electrons to flow in one direction or to flow in a particular direction in an orderly manner, and that is generating the electric current. We have already discussed this slide. Here the current is equal to Q divided by T, where Q is the charge, and as you know the charge is measured in coulomb. I is the electric current and T is the time. So if you have to find the value of electric current, you have to simply find the value of charge and divide it by the time period. You will get the magnitude of electric current. And electric current, as you already know, is measured in terms of ampere. Ampere is SI unit. It is also called coulomb per second. Electric current is a scalar quantity. As you know, a quantity can be a scalar quantity or a vector quantity. If any quantity has two aspects, a magnitude and a direction, that is called a vector quantity. Where if a quantity has only the magnitude, that is called a scalar quantity. The electric current, though it has both magnitude and direction, it is still considered as scalar quantity. There is a reason for it. The reason is electric current has only two possible directions. Take the example. If there is a conductor and that conductor is connected to a battery, this is cell, this is the positive side of the cell, this is negative side of the cell. Electric current can flow from the positive side to the negative side, or it can flow from the negative side to the positive side. There is no other way around for the current to flow. Current can flow only in two directions. There are only two possible directions, from positive end to negative end, or negative end to positive end. There is no other direction through which the current can flow. So there are only two directions possible. Second aspect is, whenever the current is operated upon, it is, for example, if it has to be added, or it has to be subtracted, or it has to be multiplied or divided. we simply follow the algebraic rules of expression. There, the vector rules of addition or multiplication, they do not apply to the current. That is why it is considered as the scalar quantity. This is a reason for it, for being considered a scalar quantity. We have already repeated this again and again, that electric current is actually the orderly movement of electrons in a particular direction. So, what is the direction of electric current? If we take a conductor and this conductor is connected to a source of power, say battery, what will be the direction of electric current in this circuit? Will the current flow from positive side of the conductor to negative side, or will the current flow from the negative side of the conductor to the positive side? Earlier it was believed that in a conductor the flow of positive charges produce current. That is, charges start from the positive side and they move toward the negative side, and here some positive charges are generating the electric current. So it was considered that the direction of current is from the positive side to the negative side. This was conventionally, historically, this was believed. But today we know that electric current flows not because of some positive charges, it flows because of electrons, and electrons, as you know, are negatively charged. You know that electrons start moving from the negative end of the conductor and they move towards the positive end. So actually current flows from the negative end to the positive end, just opposite what it was believed earlier. Earlier it was believed that the current was created because of the flow of positive charges from positive end of the conductor to negative end. But today we know that electric current flows because of flow of electrons, which are negative charges. They flow from the negative end of the conductor to positive end. But since historically we have been showing the current as flow of positive charges, we still are continuing with that convention. Whenever we show the flow of the charges, we show it a direction from positive to negative. This is the conventional fallacy, or we can say it is because historically we have been doing this, so we are continuing doing this. But in reality, electric current is not flowing from the positive side to negative side, but rather other way around, from negative side to the positive side. So for historical reasons, current is treated as flow of positive charge, but it is just opposite of the movement of electrons. So actual movement is from negative to positive. Now the summary part. We have already discussed that electric current is flow of electrons or charges through an electric conductor or electric circuit. But again, this flow must be orderly flow. They must flow in a particular or in a single direction to generate the tangible electric current. The unit of electric current is ampere, or as we said, it is also called coulomb per second. Electric current is denoted by I. We have also discussed that it is a scalar quantity, though it has a direction, but it is still considered as a scalar quantity because the vector rules that are applicable to vector quantities, they do not apply to the current. That is why it is considered a scalar quantity. And second, at a direction part is not that versatile. It only flows in two directions, so multiple directions or multiple orientations are not possible. That is another reason for it being considered as a scalar quantity. if we have to measure the electric current, we can measure it using an instrument or a equipment called ammeter, and ammeter has always to be put in a series. Mathematically, if we have to derive an equation that will help us to find the value of electric current, that equation is equal to I is equal to Q divided by T, where Q is the charge that is flowing through a cross section of a conductor, and T is the time period for which that charge has been flowing. Direction of electric current, as you know, it was historically or conventionally believed that charges flow from the positive end of a conductor to the negative end, but today that misconception was because it was believed that current flows because of the flow of positive charges, but as you know, that electric current is because of flow of electrons which are negatively charged, so they flow from the negative end to the positive end. But still, as we have been doing this for ages, we still continue with that conventional representation of direction of electric current from positive to the negative, but in reality you have to remember it is other way around. It is from negative to positive. This was all about the electric current. In next lecture tomorrow, we will discuss electric potential and Ohm's law. This lecture is created by AIIMS-HANDWARA. Thank you and Allah Hafiz.